check the randomness. Yes, sorry. I made one of those newfangled presentations where there's no words on the slides, and unfortunately all the words aren't here. Welcome. I'm wondering how many people have been in this position before. Like, you're really excited to announce the latest version of your app has gone live, and you've deployed it out to the App Store, and all the users are ready to use it. And, you fire it up on your device, maybe in front of your boss, and it goes a little something like this. So, sorry, the Bluetooth range. It's not going to Wi-Fi.
That's a good example.
Yeah, it goes a little something like this. Yeah, I'm gonna have to stand all the way over here. Oh, that works. So here's our app. It's really advanced. We're really excited to bring it to you. Let me just start it up for you. We've got this new feature here where it will encrypt all your data. Let me try that again. Okay, yeah, so I was saying, my app, we just launched today, and we added this new feature where it'll actually take the Weissman score of your encryption data before it goes to
Zero.
Shit, I'm gonna get killed. So, what do we do in this situation? Like, has anyone been in this situation before? Like, brand new app, you rolled it out, new upgrade, everything's working fine, and it crashes on launch? Yeah. So what did you do? What's the first thing you do when this happens to you?
Cry.
You cry? What do you do when you see your boss tap you on the shoulder? You want to figure out why it's happening, right? So you probably go and check your crash logs, you fire up crash logs or whatever, and you see 0.00% crash for users, which means that everything is in a really bad place. And so a lot of our talks here are going to be focused on why did this happen? What's going on with the code? How can we optimize and do these? Figure out exactly what's going on. I'm more interested in talking about how did this happen? So, what are the processes that we failed to implement as a software company that led to us shipping an app that was in this state? And how can we avoid it happening again in the future? So, I'm sure everyone here has made a small app, kind of like an experiment maybe when they're first starting out in iOS development. It seems like, the longer you're in the field, the fewer of these apps you're making. But, a new framework comes out, maybe you're learning Swift UI, so you want to come up with a toy app to demonstrate your skills. Maybe make a couple bucks for beer money. But what happens if that app starts getting big and people are relying on it, and your beer money moves into Tesla money, and suddenly you start thinking about people other than yourself, right? You're actually getting feedback and it's becoming a full-time job. Well, imagine if those thousands of dollars are becoming billions of dollars, or hundreds of users become millions, or your tip calculator becomes a full-fledged foreign exchange trading platform, and people are depending on your app for their job, for their livelihood. So many people here are working banking, commerce, healthcare, and if your app stops working, users could lose money, they could lose their livelihood, they could lose their lives potentially. And if users of your app start to lose trust in you, they'll quickly leave you. So apps of this size have something in common. They're mission or business critical. They've got lots of users, involve lots of money, and hold a lot of trust. And they're maintained by and iterated upon for years and years, and generally with a large team. There's big consequences if something goes wrong. And the companies involved have a low tolerance for risk. There's a lot of ways to minimize the chances of shipping critical bugs, but in today's world of continuous delivery, it comes with expensive speed. So I'd like to talk to you a little bit about how we can still develop quickly while mitigating risk. As you know, I'm a huge advocate of mobile development. I've been doing it for a decade. I run Tacow. I keep up with the latest technologies. I'm always fighting for Swift developers and trying to push the latest and greatest application on behalf of mobile developers. But I have to admit something. Compared to backend dev processes, mobile dev is extremely immature. So I work at Shopify. Our backend devs deploy every 5 minutes. Earlier this year, our mobile team moved from shipping every 3 weeks to every single week, or once every 30,000 minutes to once every 10,000 minutes. So this is actually this is crazy compared to the backend, but it's actually very frequent by mobile standards. Like, I don't know how many people here who have a mobile app ship every week or more. Like, that's pretty rare. In comparison, Facebook only ships every 2 weeks. So one reason why is mobile dev has a very fixed infrastructure, especially on iOS. We're relying on frameworks and tooling that are given to us by Apple or Google. Every June, we all drink from the WWDC fire hose, trying to learn everything we can in time for September and hope that Apple ships their stuff on time. We work with broken versions of Xcode all summer. We have no ability to fix these bugs. We follow radars that are unanswered. And sometimes, even when iOS 13 launches, shit still is broken, right? So Swift UI, if anyone's using it, it's still very much in flux, combined in flux, a lot of bugs. And this is the joy of working in a largely closed source world. By comparison, the tech stacks for backend and web development are largely open source. Basically, you have a baseline that you have to conform to, and that's HTTP. Anything that you want to build could be of your own choice on top of that. Your network layer, your database, your presentation, your caching, you can choose from the ground up. And by and large, they're open source solutions. So it's being iterated on constantly throughout the year. You're not waiting for your annual drop of toys for you to play with. And you know what? If the tooling for your new tech stack is immature, you can help build it. If you've ever dabbled in other technologies and used something like Visual Studio Code, you quickly realize how limited Xcode is. The ability to customize your editors and your workflow, be productive, is incredible. Of course, it comes with its own trade-offs. There's dependency hell if you're, say, a web developer. Abandonware, and changing your tech stack every 18 months, also if you're a web developer. But because of some of these trade-offs, backend web devs have processes for what Google calls SRE, which is Site Reliability Engineering. And what that is, it's a discipline that incorporates aspects of software engineering and applies them to infrastructure and operations problems. The main goals are to create scalable and highly reliable software systems. Scalable and highly reliable, that's something we clearly need in the mobile community. So some of the principles of SRE are scaling, so increasing requests. If you think about a website, they need to be able to scale for bursts of traffic. Maybe they suddenly get featured in the news and they get millions of customers or someone links to them. Control, which is rolling out updates, so how you're actually shipping the software. This isn't like back in the day where you burn a CD-ROM and put it on a shelf in the store, which is kind of similar to how we ship iOS software. Monitoring, so how you log what's going on, the performance of the app, and how reliable it is. Also, change management, which is what you do if something goes wrong. You can roll it back. So, in the backend world, as I said, scaling refers to how you can handle variable loads, usually by increasing the number of computers in your cloud deployment or instances of your other hardware. You have one app rolling on, running on thousands of machines, but in the mobile world, it's a little different. We've got billions of devices around the world, all these iPhones, literally billions of users if you are running on an app like Facebook. At the score, we had 5 million users. But the thing is, there's multiple versions of your app running on several variants of the hardware. And it makes it really hard to detect and solve problems when putting in an update because it won't fix it immediately for everyone. And this is something I've had to explain to web and backend devs multiple times in my career. Because for a web developer, every user is essentially running the latest version of the software. When they visit the site, they get what was just deployed. So breaking changes in APIs aren't as big a problem because they are constantly hitting using the latest clients. With mobile development, it's a little different. So our dream, if everyone was on the same version of our app, The reality is looking like this at best case. Usually there's a couple hundred more slivers that are progressively smaller of the users on each version of your app. So there are a couple other things beyond that. There's also OS versions. Maybe your users are unable to upgrade to the latest version of the app because Apple stopped supporting the OS of that version. Like iPad 2 was a big cliff for a lot of companies, especially if you're a point of sale company. I'm sure if anyone used something like Touch Bistro or the Shopify point of sale, a lot of people use those cheap devices for their point of sale, and they're not going to upgrade them because they don't use it for anything else. But they can't upgrade past like iOS 10, I think. So they're stranded on that version. Result in you might have to force users to upgrade, which is at some point you have to decide that these customers are no longer worth your time because the penalty of developing or supporting them is too great. You could also have a reduced user base, and you may end up having to support API versions for a long, long time and add to your technical debt. App Store versions, even if everyone did upgrade to the latest each time, there are issues with propagation. It takes a while. And some people just don't update their apps. I hate these people. But whatever the reason, you will never have 100% of your users on the same version of the app once you release a second version of your app. No. So as I was saying, Shopify ships our backend app every 5 minutes. And we have complete control of this process. We have custom tooling and entire teams dedicated to making this process simple and reliable. And this process is, it's called continuous deployment. At any given point, our master branch Git is shippable, and every 5 minutes they'll batch up a whole bunch of commits, merge and deploy them. And so it's ship, boom, maybe something goes wrong. They detect a spike in activity or crash logs, and they have to roll back. They can do it with one click. A couple minutes later, everything's back to green again. Mobile dev took a long time to get off this. There's still a lot of pretty big shops that don't do this because there's infrastructure overhead required and people needed to run it. And for a small shop, often the senior developer will also be running their Jenkins setup or their Circle CI or Bitwise or whatever CI system they're working in. It's like a second job. But it's hard to blame us. These tools for CI and CD run on servers, and the dev there, backend devs are familiar with the infrastructure. And it's not like we're going to build our own CI and CD system built on, UI kit running on a bunch of iPads. Xcode server is pretty close to this, but to be honest, it's garbage. I haven't seen it used successfully anywhere. For iOS devs, there's an added limitation that we can't just run on commodity Linux hardware in the cloud. We need to use a system that runs on OS 10 or macOS rather. Which are more expensive machines. It's a lot harder to provision a bunch of cloud machines to do this. Shopify, I think we have a pool of 200 Mac Minis in a co-located facility. And sure, it costs way more than 1,000 Linux boxes they use for the backend. And as a result, testing practices on mobile are far behind. TDD is a standard way of working in the mobile or in the backend and web world. And mobile, very few places adopted it, and test coverage is kind of an afterthought in a lot of places. And so CI lets devs ship code with confidence. They can minimize the delta between releases, which can help reduce the buzz. So this is what App Store releases were several years ago. You'd have your development phase on your master, and you'd wrap everything up and maybe produce some QA, you'd submit and praise, hope away. And reviews took weeks. There's no official beta testing program. There's no staged rollout. It was all or nothing. So you press the button, cross your fingers. Something would go wrong. You do a hotfix and request an expedited review and pray that it would get in before the damage is too great. As processes matured, the releases started to look like this. So you continue development. You might cut an internal build for people to test at your company. Then ship a test flight build to some external beta testers, and then decide to roll that out to the App Store. it's a bit better. So reviews can now take hours instead of weeks sometimes. We have beta testing, stage rollouts, and you can also cancel a rollout if it affects users. And back-end devs are probably going to gasp before this, but we've actually come a long way. The feedback is still way, way too slow. And as a result, our sensitivity to risk is much greater. So in the worst case scenario, something horrible goes wrong, your nuclear option is to force users to update the version 2 new app. This requires building that infrastructure into the system. So, on launch, you basically have to ping the server and say, can I run? Otherwise, throw up a dialogue telling the user that they need to upgrade because we've shipped a horrible security flaw. Overuse of this is a red flag. You haven't built your system to be evolved over time as well. And I see this a lot in mobile games. You'll start it up and it'll give you a message that something you need to update to the latest version. I really want to know what went wrong with their architecture for that to be required. So I have worked at places where we've had to do this, and it's always been for an extremely critical reason. So if you're processing money and there's a security flaw, you cannot let people use that broken system because you're liable for the consequences. And so in this case, if you're only shipping every few weeks, your change in the delta can be very large. And it's weird thinking of this mindset, some places will move to a monthly shipping schedule. And yeah, that's frequent compared to the days when we would box up software and sell it in store. But it's incredibly slow compared to the back-end world. And as a result, your delta is huge. You need a huge QA process to make sure that the 5,000 commits that were pushed in the last month aren't going to break anything. And maybe you'll just do some smoke testing, which is checking some core functionality of the app. And then maybe some regression testing if you're a more rigorous place. But I know at the Score, we used to do manual regression testing, and we had 5 people working around the clock for 4 days every time we put out a release, which is a huge bottleneck in your process. So manual QA can be extremely time-consuming and expensive, and QA. And so instead of proactively running QA to block releases, another approach is to instead make it easier to detect changes and roll them back. So there's a number of things we need to have in place before you launch a big app. First of all, make sure your feedback tools are actually working. I've definitely seen places where everything looks fine, but in fact the crash reports just weren't being sent properly. Or the email address in the feedback tool was going to dev null, so no one was actually reading it. And people's feedback was getting sent into the void. So what else we need to do is make sure we have metrics for determining what success looks like. Maybe just not having crashes isn't enough. We need to have some way of detecting abnormal use, or if we're launching a new feature, detect if it's being used correctly. But these crash reports that we have in places like Fabric are only good because we're telling us if something's crashing. They don't tell us if something's broken. Maybe your button that you added to encrypt something in Huli chat isn't actually doing anything. The user's tapping on it, but it's not crashing. It just doesn't do anything. So you need some core concept of service level indicators for measuring your expected usage. So imagine you have a food ordering app and you usually see 100 orders per hour during dinner time. If you're suddenly seeing half that or a quarter of that, you need to have someone watching to make sure to detect these outliers, because it's not going to result in crash logs, but it could result in a slow death of your product until people start complaining. And maybe it's not just a bug like this, it could be a poorly designed feature. So maybe your food ordering flow has updated and you added a new tip confirmation step. And because of that, you see your orders plummet because people realize suddenly their order costs 50% more than they're expecting. And they're just I'll make a sandwich. But you wouldn't know. That wouldn't come in a crash report. So, you need to have people in place to do the final analysis, logging each step and seeing where the drop-off is. That way you have, and you should also do this as part of an A/B test, so you can have control variant or control group to see if your new variant is over or underperforming. And I have to admit, I used to be heavily against app analytics, And I don't like doing app analytics for tracking, but in terms of understanding the quality of your software and the performance, it's an entirely different matter, especially when you're working at scale or with large amounts of money. Another thing that we very rarely log in the mobile world is app performance. Outside of my current job, I've never seen it done, to be honest. So on the back end, often they will have, they're the team that has like the big dashboards going with all the metrics of like their average response times, server health, cache hit percentage, stuff like that. Mobile, I've never seen that done until now. So we do things like track the round trip of a screen. So first you measure, like, do you have cache hit? What's the cache response time? What's the network response time? How much time does it take to parse that? How much time does it take to then render that? And there's overhead involved with that, but you start seeing outliers, especially if you have a large number of screens in your app. You can start seeing that, like, oh shit, like on this one page, we're requesting too much in our GraphQL response body, and as a result, our parsing time is way up, and we're doing a lot of unnecessary work. We can use that as a heuristic to find troublesome pages and thread them down. So another component of monitoring is user feedback. So as we all know, if you don't give users an easy way to give feedback, they go straight to the App Store. It's a perfect example of a process that separates small apps from big ones. When your small app is feature complete, you kind of rush to the App Store, YOLO, probably some bugs in there, and it quickly turns into this. Because writing proper feedback, handling is tedious and requires infrastructure. You need to have like a support team, and if you're one person or a couple people, you just don't have the capacity to support this overhead. So as a result, if it crashes, the user has no avenue for giving feedback other than going to the App Store, giving a 1-star review, and crapping all over your app. And once the app starts life like this, it's really hard to recover. You can game this very easily. So a couple of years ago, Apple introduced the SK Store Review Controller in iOS 10.3. And a common trick for this is to prompt users first before. So you can say, leave us a review, but before you do that, you put up a modal that says, hey, are you liking the app? Yes or no? And if they tap yes, then you say, give us a review. If they tap no, you send them to a feedback form. You can even game this more by showing the prompt when you think the user might be in a good mood. So when their favorite team in the sports app has just won a game, they're probably going to more likely give you a good review. If you have a commerce product, maybe the merchant just sold their first product of their first order, they're probably pretty happy with you and will give you a good review. So, another component that we're talking about is change management. And so this refers to how we deliver new functionality to users in the app. Backend and web development, you deploy your code to the production server, you're done. Some companies use staging servers to allow developers and beta testers to test features before they come out. And if something goes wrong with the deployment, you can easily roll it back. It's probably just a one-click process, or you deploy a hotfix pretty much instantly. And looking at the release process I showed earlier, this isn't possible. You can't iterate within a release. Once it's in the App Store, it's in the App Store. With mobile apps, the functionality is baked into the binary. Like I said before, this often blows the mind of some web developers because it's like, what do you mean? Like, it's like, no, we updated the API. It's like, yeah, but we have users like using 3 versions ago still. We have to support, we can't make breaking changes. So big industrial strength apps will actually ship functionality in the app behind feature flags for several releases before it actually goes live. And there are 2 ways of doing this. You can have client-side feature flags. So this is stuff you might be actively merging it into master, and developers are iterating on the feature, but there's no risk of a user ever seeing that code because it's basically saying, is this a debug build? Include it in the binary. Is this a release build? Then don't execute this code path or even compile it. Another way is that you can have server-side feature flags. And what this means is that periodically your app will ping the server and say, like, what features are enabled. And so you can ship, imagine you wanted your iOS and your Android and your web clients to all roll out a feature at the same time. you may have finished the iOS one in March, Android in May, web in June, and as soon as they're all shipped, the client-side feature flags are enabled. You can just set a feature flag to true on the server, and they'll all ping the server and say, "Oh, now we can show everyone a new compression algorithm," and they'll know to enable that feature, surface it to the user, even though it's been in the app for months. Apple, in theory, doesn't like this, as they say it's like a violation of the terms of service, but realistically, like everybody does this. And allows you to safely roll its changes. And maybe something goes wrong with your new compression algorithm. You can just flip that server-side feature flag back to off, and it's not a problem. And no one has to worry with it. You can also use it to roll this out to a subset of your users and test the waters, see if there's any issues, see if there's an increase in your service level indicators to show that people are actually really using this, and then you can ramp it up to 100% if you want. So, a couple different ways of doing feature flag checks on the server. First one, blocking on launch, highly do not recommend unless it's an emergency. So this is like before the user can actually interact with your app, we'll throw up a loading screen. It'll hit an API and say like, here's all the features that are enabled in this version of the app. And again, I've seen plenty of crappy apps to do this. Another one is apply on next launch. So they sometime while you're using the app, it will asynchronously hit the server, grab all the latest feature flags, write it to disk, and on your next hard launch, it will swap that out and use that as the feature flag set. And there's also just in time. So basically, as you're using the app, if say you wanted to go visit a list of your orders in your store, along the next thing about GraphQL is you don't have to do 2 queries to check a feature flag and then say get the list of orders. You can couple them into one single query, and you can say, give me the beta flag and give me the list of orders. And if the beta flag is set to true, then maybe I'll do something a little different with how I render them, or enable some other functionality. So that's just-in-time check. One other issue with app deploys is that it's hard to make users aware of new features. So pretty much every app update these days is bug fixes and performance enhancements, largely because Apple's made all the updates automatically installed, and also now they've really buried the update notices. You really have to dig to find these. I don't know why anyone even bothers writing update notes anymore. So imagine you spent months on a new feature, your compression algorithm is great, you want people to send encrypted, whatever, and you launch it and no one uses it because it's buried underneath a hamburger menu and it's just not surfaced well to the user. So some apps might use like a badge on the hamburger menu saying, look here, but one approach I like most is something that functions alongside feature flags. So this is an in-app feature announcement. So this is presented to the user on launch or when they visit an appropriate part of the app. And maybe you just enabled a feature, not shipped with or just baked into the binary, but you flipped a flag. And it now knows that on the next launch, we should let the user know that they've updated the Today widget and view on Google and all these other things. And it's right in the user's face; they can't ignore it. You could do things like direct them right to the area of the app that uses this feature just with one tap, and it can really improve discoverability of features. So, in conclusion, so some examples of how you can deploy and monitor a reliable mobile app, but it's just a subset of the development process. So there are bigger patterns of software architecture, which some of which Emily will be talking about next, which enable code reuse and decoupling and testability. There are integration testing approaches to let you do end-to-end health monitoring of your whole infrastructure. And there are also organizational structures that can allow your team to better communicate and monitor and keep track of issues as they rise. So I'd love to hear about each of these. So if anyone has experience working in such an environment and would love to share the knowledge, I would love to hear it, so please get in touch. So thank you. Any questions?
Do you guys consider post-mortem reports as part of the process when justified, for example, happen?
Yeah, so post-mortem reports, in fact, we do exactly that. Another thing the back-end world does, at the last couple of places I worked, when something goes really wrong, they write a incident report, and they do a root cause analysis. And they work backwards from the problem. They go through all the logs, when the issue was discovered, how long it took to react, and why exactly it occurred. And they will use that as a way of making sure it doesn't happen again. And yeah, so we do, for major mobile issues at Shopify, we do incident reports. Thankfully, we haven't had many, but there have been some, like where merchants couldn't log into the store. And yeah, so it's a great way of making sure this happens. Yeah.
That entire process, you have like a release cycle where once a week, is that entirely automated, like you can test like the app store?
Yeah. So we have a team called Developer Acceleration, and they build tools that on the back end it's called Ship It. We have Ship It Mobile, and it's like automatic service that runs and does the nightly builds. Like our CI runs automatically, runs a whole subset of tests, and we do nightly internal builds, and then the weekly ones, it's automatic. So you get a notice first in Slack saying, hey, if you have any release notes, update them, and then at like 2 p.m. on Wednesdays, you get a notice saying, kicking off the build. It used to be when we released every 3 weeks. We would kick off the build on Wednesday afternoon, submit to you would have 2 days of like internal testing, submit on Friday. And on Monday morning, we go live in the App Store. What ended up happening is every Wednesday morning, everyone would be like, please review my PR, I gotta get it in here, people swapping and begging, and some people kind of like YOLO merge, they like, I gotta get this in. And honestly, moving to weekly, that doesn't happen now. So our policy is like, if it's not gonna make it in for the 2 p.m. build, you can wait a week. Like, it's not critical. It's not a big deal for us to do.
Is there any manual QA about that process or not?
Shopify has 0 manual QA across the entire organization. Web, backend, mobile, 0 QA. Which terrifies me. Yeah.
I have a question. In your team, how long, whenever you estimate, does it take to merge a pull request? How long does it stay in review?
That's a really good question. So, my team, so at Shopify, we have something like 60 or 75 mobile developers. My team is me and Sanjay, who's there. And the majority of our reviewers are actually in Ottawa. So Sanjay and I give each other pretty quick thumbs up because we can roll over to each other's desks and pair together and sort it out. But getting that we require 2 approvals to merge a PR. So we have to go pay people in Ottawa or Montreal and beg them. We swap and we learn. But within normal teams where there's a critical mass of developers, they have like a 24-hour general policy for merging stuff. And that's partly why we are hiring for Sanjay and my teams. So we will reach that magic 3-person number where we can be self-hosting and review all our own PRs.
You also mentioned TDD. Do you actually do TDD this first?
No, not at all.
This is not a joke.
No, but for mobile, no, we do not do TDD. I did one for one feature, and the backend people do it, the web devs do it, but the mobile devs do not. Partly is like the test infrastructure on mobile is really bad. So on web, their test harness can detect that if you've only changed one file, it'll only run the tests that relate to that file. If you want to do that in Xcode, you have to know which file has been touched, and the system can't implicitly figure out what needs to run.
TDD largely can run web.
Exactly, yeah.
Web platform where the meantime between writing the code and actually being able to see the test, right?
Yeah,
There's no compile step.
exactly.
Interpreted, so TDD makes a lot more sense in the language that supports it, right? Cloud language is a lot harder to do, and I know loud. So I didn't argue about that. We do it at the bar.
I've even seen basic tooling like Git bisect. Has anyone used Git bisect before? So you can give it 2 commit SHAs, and say like iterate, starting from the first one, iterate through each commit, and run a test suite against it. And so say if something broke and you wanted to figure out which commit that actually broke, you go git bisect, give your two PRs, and it runs a test suite, and it gets to say the third one, it goes, and the test failed. This is the commit that broke your test. And that happens, you can run that entire git bisect in like a minute. Like you wouldn't have even finished compiling your first commit in Xcode in that time. Then you'd have to move on to the next one. You'd have to run, and it's not integrated into Xcode because Git support is stupid.
But then you say you don't have manual QA.
Yeah.
You don't write tests first. Do you write tests at all?
Oh yeah, we write lots of tests. We write unit tests and screenshot tests and state tests. So the tool that we use for mobile app development, Shopify, on iOS we use something called functional table data, and it's very similar to React. So it's like states that populate views, so we can test our states really quickly without having to render views. We do Shopify instead of QA. We have this process. I don't know why it's called this, and it sounds ridiculous. It's called top hatting. Basically, it means that when you review someone's PR, you've actually run it locally as well. And for big features, we'll have group top hatting sessions. So say we're launching a new feature, we'll document our steps, and we will manually go through it. And it's something I hate. And one of my goals for the next year is to move to completely automated testing.
How often do you release one pieces?
Very rarely, because of the 1 week process and because of the way we roll out features behind the flag. I can't remember the last time we've done a hot fix, to be honest. They've flipped the flag back off. It's all built within Shopify. There are companies that offer a feature flag as a service, and you can do things like A/B test bucketing and roll out a feature flag based on app version and device. The score had a really complex one, so you could turn it on for like iPhone 6 is running iOS 8.2, and leave it on for everyone else. So if there's a bug, or it's particularly affecting Android devices, because 5 years ago at the score, we supported something like 5,000 different unique Android pieces of hardware. Half of them had only one user. So, if it was affecting some tiny subset, we would say, like, fuck it, sorry, people on a Galaxy S3 from 5 years ago, you just can't check your hockey scores. I think it's fine. Anyone else? No? Awesome. Thank you very much. And